Today we start with solving some absolute value equations and we'll end with solving some radical equations. So again, let's start with the absolute value and let's do this kind of intuitively. If I want to solve for x and find out what number in absolute value gives me a number of positive 8, well, I know 8 is going to satisfy that in the positive type, and negative 8, because when I take the absolute value of that, it says how far away from 0 is negative 8. That's 8. So essentially what happens is, in order to solve for x, or what's in the absolute value, if I were to remove the absolute value signs, because you're not allowed to work within them unless you're combining like terms, you take the positive and negative value of that x and set it equal to the number. So therefore you have x equals 8 and negative x equals 8, and this is the long-winded way of saying the intuitive answer of x equals 8 and negative 8. If we were to graph that, actually, that would be something like, obviously this, and that graph indicates your solution. Now, we move forward and we put some stuff inside the absolute value sign, but I mean, again, this is just a bunch of stuff right here. And that bunch of stuff could be notated as some variable. Let's call it a happy face. So we've got this bunch of stuff inside the happy face equaling 10. That's really what the problem's saying. So we adapt and say, okay, well, if I want to remove the absolute value sign, I take the plus and minus of that stuff inside happy face. And you don't need to do the happy face all the time, but I'm just showing you how you do it. And now we've turned the problem into what we previously had. So I have the positive value of x plus 2, I'll just erase that, is equal to 10. And I have the negative value of x plus 2 is equal to 10 as well. So then x is equal to 8. X plus 2 equals negative 10. And negative 12 is equal to x. And if you want to solve that or check it, plug it back in, there's the 10. That's negative 10, take the absolute value of it, and you have positive 10. So in a problem like this that's much more complex, we can do ourselves a favor and isolate the absolute value first and then treat the problem as we have the other two. So I'm going to bring the 5 over, and that's going to get me a 26 is equal to 2 times the absolute value of x minus 7. Divide by 2, and now my absolute value is isolated. It's equal to 13. Remove the absolute value by taking the plus and minus of 7 is equal to 13. That means I have x minus 7 is equal to 13, and x minus 7, I'm just going to multiply the negative over right now, is equal to negative 13. So I have values of x equaling 20 and x equaling 6. So now we move into solving radical equations, and when I talk about radical, I'm talking about any root with an index in it. And in these cases, they both happen to be square roots, so index of 2, but it could be cube root, fourth root, etc., etc. So if I want to find a number such that when I square root it, I get 3, we can do that in our head. We know the answer is 9. If I want to do that algebraically, I square both sides. And when I square a square root, that's basically root x times root x, which is x equals 9. And we get the same thing. Likewise with this term, as long as the root's isolated, we can do this, and the root is isolated. Square both sides. Get 49 is equivalent to 2x plus 1. So I have 48 is equivalent to 2x, and x is equal to 24. This problem, the root is not isolated, so we should isolate it first by bringing the x over to the other side. Then we can go ahead and square both sides of the equation. In this case, we'd have to FOIL out that binomial. And we get 9x minus 9 is equal to x squared plus 2x plus 1 That's now quadratic, so we set aside equal to 0. X squared minus 7x plus 10. And then we get x minus 5, x minus 2 is equal to 0. So 5 and 2 should be my answers. Might be a good idea to check those every once in a while just to see you're getting the right answer. So I've got a 45 minus a 9 is a 36. Square root of that is 6. Minus 5 is 1. That's all good. Plug a 2 in. Get 18. Minus 9, 16. So that's 4. Minus 2 is, let's do that again. 18 minus 9 is 9. Sorry, square root that's 3. Minus 2 is 1. So we're all good. Very similar problem as the last one, although our binomial is going to get a little bit larger in a sense. Add 3 to both sides. Square both sides. FOIL. Get 9x squared. 9 and 9 is 18. And add 9. That gives me 7 minus x. Again, we're going to have a quadratic. Bring the x over to the other side. So I have 9x squared plus 19x. And that's a plus 2 is equal to 0. Let's see. I'm going to take and, let's just do a 5-step for the fun of it. X squared plus 19x plus 18. That's x plus 18. X plus 1 divided by 9 to both. And I have x plus 2 and 9x plus 1. So that gives me values of x equaling a negative 2 and x equals a negative 1/9. Now here's going to be an issue, I believe, with this problem. When I plug in a negative 2, I get 9 here, and I square root that, which is 3 minus 3 is 0. Pop a negative 2 in here. This does not work. All right. I believe actually the negative 1/9 does, though. Or does it not? Yeah, I believe it does. But you could plug that in and check. So sometimes this will be called, even though you get an answer, it's called an extraneous answer. All right, which means we got it in our calculations, but it doesn't work. And many times that will happen when you're squaring both sides of an equation. So this is much different than the last problem in that we have 2 roots. Now, you've got a couple of choices. You could square both sides right now, but understand that when you square in a sense, a binomial term, you'll have to FOIL these two together. All right, and I'm not a big fan of that just because people end up having a lot of difficulties in multiplying 2 roots by themselves in a FOIL situation. So what I would do is I would isolate what looks to be the more difficult radical. X plus 5 would be it for me. And then bring the other radical to the other side and then square both sides of the equation. All right, so this pops out as x plus 5. I get 25 minus 5 root x minus 5 root x is minus 10 root x. And then x. Bring everything over to one side because I'm going to isolate the radical now since we only have 1. The x goes away. I bring this 25 over. I get negative 20 is equal to negative 10 root x. Divide. 2 is equal to root x. And now we square both sides again and get 4 is equal to x. Once again, just pop that in for funsies. Get a 3 and a 2, which makes 5. This one's a little more difficult because the second radical is more difficult. So I will isolate one of those radicals 2x minus 2 in this case, and bring the other to the other side. I'm going to square both sides, which means multiply it by itself. This is 2x minus 2. First term's a 1, then I have a root 6 and a root x plus 6 and another root x plus 6, which makes 2 roots of x plus 6 and just an x plus 6. Again, isolate a side so that I just have its radical. Bring the 1 and the 6 over, which is a total of -7, so that's a -9. Bring the x over, and that's an x, leaving me with 2 roots of x plus 6. Now, I can divide by 2 and introduce a fraction, which I'd rather not do. So what I think I'll do is I'll take and square both sides. This foils, so x squared minus 18x plus 81. And notice I have to square this, and there's no addition or subtraction, so there's no foiling. So I square each term independently. 2 squared is 4. Root x plus 6 squared is x plus 6. And then I have x squared minus 18x plus 81 is 4x plus 24. It's going to be a quadratic, so I'm going to set that side equal to 0. Get x squared minus 22x. Then I take 81 minus 24, and I get 57, and that's a positive, equals 0. And now I have to factor, so that's going to be x minus 3 and x minus 19, I believe, is equal to 0. And again, I get a 3 and a 19. I'm curious about this one as well, so I bring the 3 in. That's a 6, and a 2 is a 4, so square root of that's 2. Put my 3 here. 9 minus 2 minus 3 is not 1, so this doesn't work. The 19, 38, 36, that's 6. And 19 and 6 is 25, which is 5, and so that's okay. So the answer is just 19, and again, this is extraneous. All right, now you notice there's no roots in here. This is not necessarily a solving a radical problem, but just kind of solving a quadratic problem that looks a little different. Now, if you think about it, there's one way that you're probably thinking about that brings pain to your mind, okay? And that means foiling all this out, finding the common denominator, multiplying it to both sides, and then like terms to one side because it's likely going to be a quadratic, and then factoring and solving, which seems like it's going to take a long time. However, note, these guys are actually the same. So what if I say, hey, let's just say happy face is going to be equal to x plus 3 over x plus 1. And let's just keep that over there for a minute. So I can then say, well, this is basically the same as whatever that happy face quantity is, plus 2, plus a happy face. And if you look at that, that basically looks like a quadratic. Like so, which I know how to factor. That's just my happy face minus a 2, and my happy face plus a 1 equals 0. Real simple factoring, right? We have 2 and -1 is equal to that happy face. However, we're not looking to solve for the happy face. We want to find x. So now we've got to come over here and say, okay, well, if I know the happy face is equal to 2, just x plus 3 over x plus 1. Likewise, -1 is equal to x plus 3 over x plus 1. And these are pretty simple problems to solve. We have 2x plus 2 is equal to x plus 3. So x is 1 here. And then in this case, we have -x minus 1 equals x plus 3. And I have, let's go 2x equals negative 4. So negative 2 is equal to x. Are they always going to be opposites like this? Answer is no. But in this case, they were. Okay, now, in theory, this problem could be written as a radical problem. All right, we could write this, because we know about rational exponents now, as a cube root of x minus 4 squared is equal to 4. All right, and if I was to solve that, I'd cube both sides and square root both sides and then isolate. That would be me. All right. However, we also know a little bit about rational exponents and properties of exponents. What if I was to take and say, well, I'm going to take this guy and raise it to the 3/2 power. And if I raise that to the 3/2 power, I have to raise this to the 3/2 power. All right, so in doing so, notice what's going to happen. 2/3 times 3/2 is equal to 1. And that radical is gone to begin with. Now, the only thing you're going to have to keep in mind here is you've essentially, by using an index of 2, which is what this would be, you've essentially square rooted both sides. All right? And when you square root both sides of an equation, all right, you're going to have to make sure that you take a plus and minus. All right? Because if I take and square root an x squared, okay, there is a positive and negative value that comes out of this, all right? Because if I said square root of x is equal to 2, I could have a positive 2 in here or a negative 2 in here, right? And get the same answer. So another way to think about this is whenever you square root an x squared, you get the absolute value of an x, and that is the square root of 2 in this case, if I'm doing this. And then you take the plus and minus of that to get x, right? So in this case, I'm going to have to take the positive and the negative value of basically the square root of 4 cubed, all right? So in this case, I have x minus 4 and plus and minus 2 cubed, right? Which in this case is plus and minus 8. So I have x minus 4 is 8, and x minus 4 is negative 8, which gives me answers of 12 and gives me an answer of negative 4. Similar problem, different radical, probably take it the same way. Looks a little more difficult because I have a fraction in here, but again, I would likely go ahead and raise this to the negative 4/3 power. You don't have to do it this way. If you want to set this up as x plus 2 4th rooted and negative 3rd power, you knock yourself out. Go ahead and do that, okay? But I like this way better. So this is going to be negative 4/3 power. This goes to a 1. Negative means take the reciprocal, take the cube root, and notice because you're cube rooting, you don't have to go plus and minus, and raise that to the 4th power. That's x plus 2. The cube root of 64 is 4. Cube root of 27 is 3. Raised to the 4th. So this is a negative 2 plus 4 to the 4/3, which is 256. And 3 raised to the 4th is 81. All right, and you can solve that from there. If you're not sure how to solve this, or if you are feeling like you have to go, well, I must multiply this by 81 over 81, you're kind of wasting your time. Whoa. What I would do is I would go to your calculator and hit the following buttons in this order. All right. Basically, you go -2 plus, and then go 256 divided by 81. And then there's a math button on your calculator. If you hit the math button, a new screen will come up, and you'll notice at the top of that screen, there is the word frac. And if you hit that button, it will take your input of -2 plus 256 divided by 81. And if you've hit math frac and hit enter, you get 94 over 81. All right, handy little button. If you need help on that in class, feel free to bring it up, and we can go over that little calculator trick. Okay. Other than that, we're done for the day. See you next time.